Pre-calculus, reciprocal trigonometric ratios, part 2. In part 1 we dealt with the definition of these ratios and several of their properties, summarized in this screen now. The co-ratios often used in trigonometric equations. Notice here under reciprocal I've only put the cosec and sec because this is under identities. With cot, what we would usually do is go to sine and cos, so therefore that fits under the quotient identities. And here are our three Pythagorean identities with the spin-offs, which we can use directly in identities or equations. Let's have a look at general solution involving the reciprocal ratios. Of course, with these we go automatically to the primary ratios, so it's very much the same as what has happened before in trigonometry. So the first thing we do is we say, well, cosec of alpha is negative 3,124, so we convert that to sine of alpha by inverting the 3,124. We set it up. A reminder, do not enter anything on the calculator yet. First of all, reason that sine of alpha being negative means that it's in the third and fourth quadrant, so you write 180 degrees plus blank plus k 360 degrees, k element of z, 360 degrees minus blank plus k 360. There we haven't had to use a calculator, we've left a space for the key angle, and we're now ready for the key angle. Now we're going to substitute 0.3201 into our calculator with sine to the minus 1, the inverse sine, but do not enter the negative. We've used the negative to determine the quadrants. Do not enter the negative again because it's just going to cause you complications. And there is what the calculator will give us. And that's it. We do not have to write k element of z more than once in the question. In this first case, we need to solve first of all for 3 theta. We cannot get rid of that 3 without getting rid of the cot first. And if you notice, we've got cot equals cot. So therefore, if cot this equals cot that, then these two must be the same, allowing for quadrants. But of course there's a negative, so therefore it brings a bit of a twist into it, allowing for quadrants. Cot equals a negative value, well, that being second and fourth quadrants, 180 minus, 360 minus, and then there's the 3 theta. There is your key angle, so we can slot that straight in as the key angle there. This gives us two equations. The first one, move the negative theta across that side, 180 minus 20 degrees gives you 160 degrees. And we solve for theta. Notice that I've divided the k360 by the 4 as well. Then we go to the second equation. Also negative theta going across give you 4 theta, and 360 minus 20 give you 340 degrees. Dividing by 4, there is our solution there. Now this being cot, and with tan, they have a period of 180 degrees, which means every 180 degrees they repeat. So therefore we, instead of having two answers plus k360, we could just have the first answer or the second plus k180. So there I've taken the first answer. Instead of k360 I have k180, and I need no more than that. I solve as I did before, and I end up with 40 degrees plus k 45 degrees. We're not missing the 85 degrees because, in fact, if you add 145 onto 40, you get your 85 degrees. That's the useful thing about tan and cot. There's no harm in having done it that way though, so don't feel you'll lose marks. Some more general solutions to try. Now, this one's going to bring in one of the Pythagorean identities. We cannot solve that like that, but I remember that sec squared is tan squared plus 1. So if I put tan squared plus 1 instead of sec squared, I'll end up with just tans in the equation. Simplifying, we get that. Now that's like a normal old quadratic equation where all we have to do is take out a common factor of tan. Now either tan is 0 or tan theta plus 1 is 0. Give you tan theta equaling 0 or negative 1. Theta is k 180 degrees for 0 because tan is at 0 every 180 degrees. And then we can set this up. We say, well, it's second and fourth quadrants. Key angle 45 degrees. So it's going to end up being second quadrant 180 minus 45 degrees plus k 180 because it's tan. We don't need to go for the fourth quadrant. In this next case, tan equals cot. Well, we can do nothing with that as it stands there. But using co-ratios, tan theta is cot of 90 minus theta, or cot of 90 minus theta is tan theta. I can convert this to tan or this to cot. I'd rather go the tan way. I'm more used to tan. So therefore, I'm going to say instead of cot of alpha plus 10 degrees, I'm going to say tan of 90 degrees minus alpha plus 10 degrees. And simplifies to that. Now at that stage, I have tan 2 alpha equals tan 80 minus alpha. So therefore I can say 2 alpha equals 80 minus alpha for first quadrant, or 2 alpha equals 180 degrees plus 80 minus alpha for third quadrant. Being tan though, I can just go for one answer. 2 alpha equals 80 degrees minus alpha plus k 180. So that gives me 3 alpha because negative alpha moves across, and there is my solution. Some examples to try yourself. We've gone back to some identities. Pause and try them yourself, and the answers follow. Now with this one, there are a couple of ways you could do it. You could change to sine squared over cos squared and multiply out, or you could multiply out and then change to sine squared over cos squared using the left hand side. But if you're observant, you will notice there that we have tan squared alpha plus 1. We'll have a look. Tan squared theta plus 1, sec squared theta. And 1 minus sine squared alpha, you must be used to that. That comes directly. It's a spin-off of sine squared plus cos squared equals 1. So I'll take left hand side. That becomes sec squared. That becomes cos squared. Now we don't have to have the step. We could go straight to the answer of 1 because they are inverse. They are reciprocal ratios, but let's slot it in for you to see. So sec squared is 1 over cos squared. These cancel, giving you 1. This next one, I'm going to go for the left-hand side because I'm going to convert, and then there's a whole lot of algebra there. So we need to convert to sine and or cos. Divided by sec squared, sec is the inverse, that's the reciprocal of cos, so instead of having sec squared below, we could put cos squared above. So you'll see on the next line, I have multiplied by cos squared, instead of dividing by sec squared. Cot, cos over sine, tan, sine over cos. Now there's the algebra, common denominator of sine theta, cos theta. On the top line, sine squared plus cos squared, there it is there. 1 This can cancel cos theta into that cos squared theta, give you cos over sine, and that of course is cot theta. This one looks terrible, but have a look. As soon as I see sec squared or cosec squared, I think, well, what about the Pythagorean identity? So I have a look and I'll say, well, sec squared is tan squared plus 1. Well, that means sec squared minus 1 is tan squared. So there's your tan squared. Cosec squared is cot squared plus 1. So cosec squared minus 1 is cot squared. So left-hand side, we have that. Notice, multiplying by cos squared, because we're dividing by sec squared. Now this cot squared, instead of going to sine and cos, why don't I just take that to the top and make it tan squared? So we end up with tan to the 4. Square root of tan to the 4 is tan squared. Now we're going to change into sine and cos. And that ends up as the right-hand side. Our trig equations, cot squared and cosec, but then cot squared, it rings a bell, there's cot squared. So I can write it as cosec squared minus 1. There we are. Now that is a quadratic, just get it in the right order. This is like a squared plus a minus 1 equals 0. It won't factorize, so we'll have to use quadratic formula. Negative b plus or minus the square root of b squared minus 4ac, all over 2a. There's our answer to that. Now, cosec is the inverse, the reciprocal of sine. Now, sine has a range between negative 1 and 1. Sine doesn't go above 1 or below negative 1. Now, the reciprocal of that can't be between 0 and 1, so that's not acceptable. So therefore, we're going to take it out. As it says here, the same applies to sec. Cannot go between negative 1 and 1. So now, using the calculator, I'll set it up 180 plus, and I'll leave a gap, plus K360, K element of Z, 360 minus, I'll leave a gap, plus K360, because cosec is negative in the third and fourth quadrants. Now, I'll just simplify, and there is our answer. The second one, well, we have sec equals negative cosec. Now, if it was sec equals sec, I could just equate the angles for two quadrants. But the sec equals negative cosec, which means that I must convert this to sec or that to cosec. Let's convert cosec to sec with a 90 minus. So now we have sec of 90 minus 30 plus x, which simplifies to there. So now sec 30 minus x equals negative sec 60 minus x. So we can now say, well, that means I can equate 30 minus x to the other quadrant equivalent of 60 minus x, which means that 30 minus x is going to be 60 minus x in the second quadrant and the third quadrant. So 30 minus x equals, we're going to treat that as the key angle, 60 minus x, and we're going to say 180 minus the key angle plus K360, K element of Z, and 180 plus the key angle plus K360. Simplifying the right-hand side, why have I crossed that one out? If you simplify it, you're going to end up with a 0 equals 210 degrees. That's a no-no, impossible. So therefore, I'm going to take this x to that side, give me 2x, 120 to that side, give me negative 90. I can take the k360 across, give me negative k360, but k is an integer, so therefore I'm going to leave it as plus k360. Divide through by 2x, negative 45 plus k180. And 135 plus k180 is fine. All I've done is added on a 1 k180 if you prefer. Cos minus sec equals 1. Pretty straightforward. I'm going to convert that to cos. Multiply through by cos. Keep in mind now that x can't be 0, but we're not going to end up with that. Quadratic equation to solve, we're going to use quadratic formula again. And we're going to reject that answer because cos goes between negative 1 and 1. The range cannot be above 1. Now cos is an interesting one. As with tan, where you can do just a single quadrant with plus k180, cos we can do 2 quadrants, or we can do 1 quadrant with a plus or minus on the angle. And this is what I've done here. Cos x equals plus or minus, where's cos negative, second quadrant, 180 minus 51.8 degrees, plus k360, k11 of z. If you take the negative of that, you'll see it'll actually give you a third quadrant angle where cos is also negative. Simplifying, there's our answer.